Okay guys, welcome back to class, yay. So this lesson has the potential of being complicated, so I'm gonna do my best, take my time. If you have any issues, definitely contact me or even search YouTube for other videos that might help. I could even, if I get a lot of questions, I may start linking extra videos if I find some. All right, so the topic is evaluating arithmetic series. Yesterday we talked about arithmetic sequences. We also talked about geometric, but today we're just still going to focus on arithmetic. So from yesterday, a sequence is a pattern of numbers, which you can see I've written so eloquently right here. Just a pattern. A series is where you add up the numbers in that sequence. So it'd be like this. A sequence would be 2, 4, 6, 8, 10. That's a pattern of numbers. It goes up by 2 every time. A series would be 2 plus 4 plus 6 plus 8 plus 10. So that's kind of the big difference here. So this is a sequence, and this is a series. Very closely related, but not exactly the same thing. So finding the sum in a series, like problems 1, 2, 3, and 4, you could do something like here in number 2, 5 plus 8 plus 11 plus 14 plus 17. Type that into your calculator, get an answer, and that's all well and good. This gets kind of old after a while, especially if instead of having 5 numbers to add together, maybe you had like 55 or 550 numbers or 1,000 numbers to add together. Then it gets to be kind of a pain. So what we're going to do is we're going to go over a formula which gives you that answer without having to add all the numbers. Now, as you can see in the homework, you could very easily just add those without the formula and you'd probably be just fine. But I want you to practice the formula because this would have, an application for, tons of numbers, dozens of numbers, hundreds of numbers, whatever. And it's a quick and easy formula. But then there's also this thing called sigma notation. Oops, look at that. That looks very, very technically mathematical, complicated information stuff, doesn't it? And so that's another thing that we want to talk about and get you to understand. So it's called sigma notation. Sigma is this capital Greek letter right here. It means sum. And again, in a series, we're adding numbers together, adding, sum, same thing. So in sigma notation, you have the sigma. You have a variable equals below it. The variable is called the index, and then a starting number. And at the top of the sigma, another number, which is the ending number. And then in parentheses, you have basically a formula that creates the pattern of numbers. So here we have sigma, or the sum, as m goes from 1 to 4 of 2m plus 5. So what that means is you're going to plug a 1 into this formula, which I have right here. Then you're going to put the plus sign and plug a 2 into that formula, like I have right here. And then another plus sign. Then you plug a 3 into that formula, like I have right here. Then another plus sign. Then you plug in a 4 in for m into that formula, like I have right here. And then I stop at 4 because 4 is the last number. But you could see if instead of 4 that was like 40, that this sum would be quite lengthy. It would go on and on and on and on. There'd be 40 of these things. But here we only have 4 of them because that's what the sigma notation tells us to go to. And then you add that all up. So here you're given just the list of numbers and you're expected to add them all together. Again, you could use a formula or you could use a calculator. And here you're given sigma notation. Now number 6, if we wanted to expand this, and we really don't, but I just want to do this to try and help you understand sigma notation. What this means is I have to plug in a 1, then put a plus sign. Then I need to plug in a 2, plus sign. Then, then times 3, plus sign. Then times 4, plus sign. And I have to keep on doing this until I get to the end where I've plugged in 25. So there'd be a total of 25 terms there. Of course, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 24, dot, 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 all the way up to, what's 6 times 25? 6 quarters is $1.50, so 150. So this sigma notation, here, that's looking a little sloppy. This sigma notation is a shortcut way of writing this whole thing out right here. Something like this, we could also create a sigma notation. It'd be a little complicated, but do you see here that these go up by 3? The common difference is 3 every time. So this is going to be 3n. The first number is 5, so I'd have to add a 2 to that. And n would go from 1 to 1, 2, 3, 4, 5 numbers. So here, this isn't kind of the focus for today. I'm just kind of throwing this out there. This is a sigma notation for that number pattern. Now you can check it. Plug in a 1. 3 times 1 is 3. 3 plus 2 is 5. Plug in a 2. 2 times 3 is 6. 6 plus 2 is 8. Plug in a 3. 3 times 3 is 9. Plus 2 is 11. See how I'm getting the same numbers? And then I keep on going. Plug in a 4. 3 times 4 is 12. Plus 2 is 14. Plug in a 5. 3 times 5 is 15. Plus 2 is 17. Once you get to 5, you stop because that's the top number. And so now that is the same as this, except I put in plus signs instead of commas. So the number pattern, the sigma notation is just a substitute for the number pattern. So you could be given the number pattern, and then you're expected to add them. You could be given the sigma notation, and your expectation is to add them. We want to avoid just typing a ton of numbers into a calculator like this. That would be awful. We're going to go over the formula which solves it. So this is where the rubber meets the road. This is the thing you absolutely have to know how to do. To find the sum of an arithmetic series. Remember from yesterday, arithmetic series have a common difference called d. And, oh, that doesn't even matter here. The sum doesn't have d in it anywhere. Why? There's no d in that. So forget that. I'm just going to erase that. Okay, so to find the sum of n numbers, you do n times a1 plus a2 divided by 2. Okay, so what is that? N is the number at the top. Excuse me. N is the number at the top of the sigma notation. A1 is what you get when you plug in a 1. A1 is the first term. Plug in 1. AN is the last term. Plug in top number. Okay, so when you're doing a problem that's written as a list, you don't have to worry about any of this stuff. So we'll do a couple of those and use that formula and just hopefully see how easy it is. So the sum of n numbers equals n times a1 plus an all over 2. Okay. So what is the sum if we add these together? Well, what is n? How many numbers are there? 1, 2, 3, 4, 5. So this number is a 5. A1, what's the first number? 5. Plus an, what's the last number? 17. All divided by 2. 2 is a constant that never changes in this formula. So let me pull up the calculator. And I'll hit the fraction button. 5 times 5 plus 17, all divided by 2, and you get 55. Now you may be thinking, Haskell, it's a lot easier just to go 5 plus 8. Oops, that's times. I'm smart. All right, 5 plus 8 plus 11 plus 14 plus 17. Same answer. Why not just do it that way? I'm not going to argue with you. That's definitely easier in this problem. But again, if there were 100 numbers here, you'd still be typing and typing and typing and typing and typing. whereas we'd be done with the formula a few minutes ago. So it's good to learn how to work out and use this formula. Let's look at number 4 then. We want to, again, add all of these numbers together. So how many numbers are there? 1, 2, 3, 4, 5, 6. 6 of them times the first number, negative 9, plus the last number, negative 19, all divided by 2. So fraction bar, 6 parenthesis, first number plus last number, all divided by 2, and negative 84 is the answer. Let me go down and check 2 and 4 just so I can stay on track. So that's, of course, right. And there we go. So for 1 and 2, you're going to use this formula right up here and use my examples. And please do not, I mean, I can't control you, but please don't just add these up in the calculator. Don't type that in. Get familiar with the formula. It's kind of a trivial problem, but, you know, better to learn on an easy example than to learn on a hard one. If I gave you a homework problem where there were hundreds of numbers here, yeah, that wouldn't be so great. Okay, so 1 through 4, hopefully very easy. Obviously, you're doing 1 and 3. Hopefully very easy. The formula, A1 plus A2, N over 2. Wow, struggled just to say that. Okay, now for the rest of it, we need to apply that same formula, but in sigma notation. And this is brand new. I'm going to rewrite the formula over here. So Sn equals n times A1 plus An all over 2. So before I just start plugging numbers into a formula and working it out, I need to identify some things. First of all, what is n? In this problem, n is 25. N is always the top number. So we know what we need to plug in there. What is A1? Again, A1 stands for the first term. You get the first term by plugging in a 1 right there. 6 times 1 is 6. Next, what's An? An, in this problem, is A25. That's what you get when you plug this last number in. Right, well, here, I'll do an arrow like that, right there. So 6 times 25 is, oops, I wrote that down wrong. 6 times 25, I think it's 150, is 150. So our sum is going to equal 25 times 6 plus 150 all over 2. So fraction bar, 25 times 6 plus 150 all over 2, 1,950. If we're to add all 25 of those numbers together, we should come up with 1,950. And yes, that is correct. Okay, so number 8. Before we do anything, we need to identify n, A1, and An, which in this case is going to be A15. So n is the 15. A1 is what happens when you plug in a 1. 8 minus 7 times 1. What's 8 minus 7 times 1? That's 1. A15, so you plug in a 15. 8 minus 7 times 15. Oh, I can just change that to a 15. That's negative 97. So my sum equals 15 times 1 plus negative 97 all over 2. Oh, I got too many things on my calculator. Okay, so fraction bar, 15 parenthesis, 1 plus negative 97 all over 2, negative 720. Let's see, number 8, negative 720. There it is. One more time. Repetition is good. You see it done a few times. You can watch the video over and over if you need to, and hopefully it'll click. How do you use this formula? So you have to know what n is, what is A1, and what is the final A, which we would call A45. N, of course, is that 45. A1 is what happens when you plug in a 1 right here. 10 times 1 minus 8. 10 times 1 is 10, minus 8 is 2. A 45 is what you get when you plug a 45 in right there. 10 times 45 minus 8, which I'm not going to try to do in my head. Yeah, I am. 450 minus 8 is 442, but I don't trust myself. 10 times 45 minus 8, 442. So what is the sum of adding all 45 numbers together? 45 times 2 plus 442, all divided by 2. So fraction bar, 45 parenthesis, 2 plus 442, all divided by 2. I come up with 9,990. Is that right? Yes, it is. Okay, so again, you're in pre-calculus. We're just about done. This sigma notation is huge in calculus. We're just kind of doing some basic stuff with it. We're wrapping our brain around the notation itself and what it means to add these numbers together. So what we're doing right now using this sum formula, kind of a very elementary operation when it comes to the whole world of sigma notations and sums and things. We'll advance a little bit, but let's face it, the school year's almost over. We're not going to get super deep into this. But just a quick review. From yesterday, a sequence is a pattern of numbers. Oh, I guess it's not yesterday. I guess it's 2 days ago. Sequence is a pattern of numbers. Series is what you get when you add up the sequence. You can either be given the list of numbers, which you could theoretically just type into a calculator, or you can use the sum formula, or you can be given sigma notation like these, and it's still just a matter of using this formula. You need to have n, which is the number of terms, the top number in sigma notation, a1, the first term, and an, the last term. Plug all that in, and you'll get your answer. Okay, as always, contact me if you have questions, or maybe Google search arithmetic series on YouTube and see if you come up with any additional videos if you need help. Otherwise, good luck, and I hope you have a great day. Bye-bye.